Hi, my name is Parsali Mohammadi. I'm electrical and electronics engineering student. I'm taking this video for Physics 102 lab experiment. I'm from Physics 102 section 5, and in this experiment I'm going to investigate back EMF in custom built BLDC motors. First of all, what are BLDC motors? They are normally known as brushless DC motors, that they are different compared to traditional uh, electric motors since they don't have brushes, and they have wide range of uses in areas such as robotics. Well, in this experiment I decided to build and design a custom BLDC motor in which I 3D printed it. Well, I started the whole experiment by researching and find some specific design formats for BLDC motors, and I choose 12 and 16p BLDC format for my own custom built BLDC motor. Then I started to work with CAD programs, especially with Fusion 360 to design my BLDC motors. Well, I decided to work on something easy to work and practical. So I built a specific type of BLDC motor such that so I could change the parts like stator core, which is this one, without changing the whole design, and I could just unscrew these parts and attach other parts of stators like this one or even this one. This one was different since I used some screws here to change the core material, like this one, 304 stainless or 12.9 class stainless steel. Well, each of these stators had a specific resistance type, which I tried to show them with color change of the wires. For example, blue one had a different one, yellow one had a different resistance of the coils. After finishing the design of the BLDC motor, I tried to design a specific type of electric motor stand so I could change the RPM and experiment with specific each motors. In such, I could just attach BLDC here which had magnets, and I can just change them easily. This one, I had a motor controller and Arduino in which I can change the speed or RPM according to experiment values. Well, right now I'm going to put the videos of the experiment. So, yeah. Okay, if you watch the experiment videos, you have some understanding and some ideas about my experiment setup, in which I was using an Arduino which was connected to my laptop, and I was changing the RPM values in my pre-built BLDC motors, and I was rotating my own custom BLDC motors, in which I was monitoring the values on oscilloscope. Well, the whole experiment started with 20% of the throttle of my BLDC motor I used, which was 2220 RPM. In second video, I used only 60% of the throttle, which was 6660 RPM. And in the third one, I used 100% of the throttle, which was 11,100 RPM. In this experiment, I was trying to show the connection between velocity, angular velocity, and RMS or back EMF. But if you notice on the oscilloscope, the y-axis or delta y was getting wider and wider. This was the E peak, but not back EMF of the BLDC. It was induced by the coils and magnets in the BLDC motors, and they were similar to just normal generator. But if we are looking for back EMF, we have to use another formula, which is written as E RMS equal to E peak over root 2. This is the formula we use to get back EMF. But if you ask, what are we going to do in experiment and what's the purpose of this? We were trying to find the effect of different factors in back EMF. Factors such as coil resistance, core material, air gap distance, and angular velocity. And the results of the experiment were really interesting, but they were really close to theoretical data and data written in the sources. Mainly, let's start from angular velocity versus RMS or back EMF, which were closely related, and with the increase of the angular velocity we had a linear increase in RMS or back EMF. In second case, we had winding resistance versus RMS back EMF, in such that with the increase of the resistance, the back EMF was increasing. And then we had the core material change, such that we had lowest back EMF by using 304 stainless steel and highest back EMF with 12.9 class steel. We collected the highest RMS. And then at the end, we had air gaps. As I said, I was using a special type of stator that I could unscrew different parts and change the screw or change the distance of the screws like this. Well, when I'm saying a specific value, I was talking that I rotate or unscrew this one 1 millimeter or 0.5 millimeters. And by doing this, actually we were getting closer to the magnets, or coils getting closer to the magnets. And in this part, we had with the increase of the coils, distance between coil and magnet, we had higher RMS or back EMF, which showed a linear relationship between them, and it can be decided or can be shown that with the lowering the distance, we can get lower back EMF too. And at the end of this part, I'm going to put the results of the experiment and tables and data to have a better understanding of the experiment.